What's up, hobby friends? In this video, I just wanted to briefly share on a bit of a disaster that I had earlier this month, how I've tried to triage the mistakes that I've made, how I've learned, and what I'm going to be doing moving forward, and just covering some stuff that I wish that people had shown me or told me, or stuff that had been made more easily accessible when I first started 3D printing. So two things that I learned when I began my 3D printing journey. The first was to print your objects hollow, especially larger pieces where it's a lot of wasted resin to have to print the internals. So for example, you see on the screen is this shipping container. It's a pretty big object, and if we were to print this entire thing as a solid piece, it ends up using almost 300 milliliters of resin. That's quite a lot, and it costs, you can see, about $17 Canadian. So one of the things that I learned was to print it hollow, and you can essentially specify in your slicer of choice the depth of your, or the thickness of your walls. And then something that was also shown to me was the idea of using infills. Now, infills are essentially a lattice structure that's added to the interior of an object that helps to improve or increase its structural integrity, and especially if there's going to be any sort of weight or pressure placed on the object, helps to reinforce its solidity, I guess, for lack of a better word, it prevents it from just collapsing in on itself. When I started printing, I experimented with 1 and 2 millimeter walls, and then I was using 40% infill, basically using 40% of the space inside to create a lattice structure and then improve its integrity. What I didn't account for was the fact that this would potentially trap resin inside. And so essentially what will happen, if I can show you here, set it to 40. And so you can see that the slicer adds this structure inside. So despite hollowing the piece, it's not quite hollow. It does have this cube structure inside. And essentially this is a semi-hollow space. But as the 3D printer prints in layers, starting from the plate on the bottom, it's closed off. And then once it finishes printing, it is again closed off. So there is excess liquid resin that is trapped inside that now can't get out. And what happens when you cure resin, it shrinks. So what happens is when we're UV curing the outside shrinks just a little bit, but the inside, because we're not using a clear resin and it's not being exposed to any UV rays, maintains at its uncured printed state. So it has been exposed to some UV light from the 3D printer, but the curing process hasn't been finished like the outside. What ends up happening is that the outside shrinks at a larger rate than the inside because they're being cured by two different sources. And if your 3D printed walls are not thick enough, this can lead to cracking, especially in corners where the actual thickness of the piece might not necessarily be the full 3 millimeters. Something like this corner right here might actually be only 2 or 1, right? And so what's happening is that this liquid resin is now getting into the cracks, and it's causing a chemical reaction that essentially creates or causes these cracks to continue to expand over time. And this will vary depending on the piece. I had a couple of pieces that went maybe 1 or 2 weeks before cracking. I had others that went a month and a half. But once the crack appears on the surface and it exposes the internals, the uncured resin and the liquid resin to air, it just causes a cascading or a chain reaction that continues to split all the way through until the resin is removed, it's rinsed out, it's cured, whatever. And that's essentially what happened to quite a few of my prints that I had made very, very early on. A lot of the scatter terrain that I made for my subway, including a lot of the benches, the vending machines, ticket booths, they were all done with 2 millimeter walls, plus 40% infill, but no drain holes. And essentially what was happening was this chemical reaction of the uncured resin caused these cracks to appear, and then the moment that the cracks reached the surface and exposed the internals to air, everything just exploded and it was apocalypse. So how do we solve this problem? In doing research into the reason for the cracking and how to alleviate it, essentially the general consensus is to create drain holes, at least 2 if you can, if not more, into the piece so that when you're printing it hollow, you're giving room for the excess resin to be able to flow out as it's printing. And then you can also pour out and rinse whatever is inside, and then potentially sneak in a UV light to try and cure the inside, just like you do the outside. The second is to increase the thickness of the walls. So for the future printing, I'm going from 2 to 3, or in some cases 4, if I really need this object to be sturdy and I don't trust some of its angles to properly maintain its integrity without cracking. And then the third actually is to print with no infills. 1, this will save on resin, and then 2, this will also help to prevent any sort of pushing or pulling from the actual infill lattice structure onto the external walls of the print. So the latter 2 are fairly easy, increasing the depth of the walls as well as not printing with any infill is a pretty straightforward process. It's all just about setting up the right settings. We do no infill, and then we print it hollow. So you can see already that without the infill, we're going to have a much lighter object. We've cut down the actual material and weight of it by 1/3, 2/3, I guess. It's 1/3 of the original weight as well as cost. So it's definitely a lot cheaper now to print. But then how do we go about adding the drain holes? So adding the holes themselves are fairly easy. In your slicer, we go to dig hole. We want to set our depth to just a little larger or a little wider than the actual thickness of the wall itself. So because I have it set to 3 millimeters from my wall thickness, I want the depth of my circle to be at least 4. The size will vary depending on the actual object itself and how large you want the hole to be. I would say go as large as possible on the object, especially if, like on the shipping container, it's going to be hidden on the bottom. If you need all 4 sides to be visible, then you might want to either consider printing it as a solid object or finding some way to hide these drain holes in a way that you can either fill them up or build over them in some way to hide them. You can also make these holes and keep the holes. So if you want to then print the object and then insert it in afterwards to plug the gap, that's perfectly okay. However, keep in mind that because resin does shrink a little bit when it cures, this external piece might not actually fill the hole perfectly, and you might still have to MacGyver a solution to fix it. So basically what you do is we're going to set this to 20 millimeters, and then we're going to add a hole, and then we're just going to drop it in. So you can see that by adding just a couple of holes, it gives room for the resin to escape, to be able to pour out as the object is printing. And then once we clean it, we can rinse the inside. And if the holes are big enough, I can just use my wash and cure station to shine some UV light in there, or maybe get a UV flashlight and just quick cure the inside of the print. So the way that I am setting up my printing objects now, especially when it comes to terrain, is there's always a side that is typically not visible. This is usually where it sits on the tabletop. And that's where I'm setting up my supports with the rafting. And then that's also where I'm creating my drain holes. This allows me to actually hide this part of the printing process without having to worry about plugging the gaps or doing any sort of extra work to try and hide these kind of holes. Unfortunately, because when you're 3D printing, the raft is printing upside down, the object does print like this. And these drain holes don't really do a whole lot when gravity is going to keep the excess resin on the inside. For the time being, what I usually do is once the object is done printing and I'm taking the printing plate off of the 3D printer, I'll just hold the plate at a 90-degree angle, so perpendicular to the resin tank. And I'll just give the resin a couple minutes to drain out. Typically, it's not a whole lot. I just want to get most of the excess resin out. But most importantly, the drain holes will, when I'm cleaning the print, allow me to thoroughly flush and clean the inside. And then with the holes, if they're large enough, I can then get UV light in there to cure the inside. If you want to have the resin drain as it is printing, what you're going to have to do is actually orient the object with the holes at a downward angle, at some sort of position, so that when you are printing, the holes do face downwards towards your towards your resin tank. And this will allow the resin to fully drain out as you are printing. But one thing you have to consider then is as you apply your supports, you may have to then go in manually and apply supports to where they're easier to clean. On an object like this, if you auto support and they auto support into some of these angles and panels are very difficult to reach to with sandpaper or whatever, you may have a harder time cleaning it and a lot more work involved. So that's just something to keep in mind when you're setting up your prints and accounting for how you're orienting the drain holes and how you want the resin to drain. Thankfully, not all is lost, and I'm able to salvage a lot of these cracked and broken 3D printed elements into some terrain and debris for a future table. What I ended up doing was just 3D printing a large trash dumpster, and I'll be rearranging and using these already printed objects that have been broken or cracked as essentially trash in the landfill. So thankfully that's been a silver lining to this entire adventure and just another part of the learning process, I guess, of 3D printing. This is one of those things where I wish someone had either told me straight up or had been more readily available in the research. This was just one of those things where you don't know what's going to happen until it happens, and you don't know that you need to account for this until you have to actually fix the problem. So I hope that you can learn from my mistakes and that when you approach your own 3D printing, this is something you keep in mind to avoid the kind of headaches that I had to deal with this month. So I hope you enjoyed the video. If you want to check out my other social platforms, I'll make sure to drop links in the description below. And as always, until next time, happy hobbying.